So we're kind of, I'm going to continue on a little bit where we left off, but talking about why we need to manage security and security management and some pieces of it that kind of fit it all together. And business management, security management, bringing them two together, and then bridging the gap between the different types of networks that I identified before. And then finish off with looking at the ecosystem for security that involves multiple kind of companies, industries, and whatever, and how that whole ecosystem kind of maps together when it comes to securing products to answer these two questions that I'll put back up here. How do we trust these countless devices out there? I mean, this is the ICS-ISAC. We're all about data, gathering data, lots of information. When it comes from these millions of and ever-growing embedded devices all over the world, how do we know that we trust that data? We can collect it all day and have big data that we can't analyze because there's so much. But then what it comes down to is how much of that is valid and how do I trust it? And I've heard some talks of people from big data say you don't care whether you trust it or not. But at the industrial control level, we know it matters because data does electromechanical operations, and we can't ignore that. And so security has to be addressed at this trust level and accountability of communications. We have a question on that?
Yeah. So each level you're down to the control level, you're running the distributed systems. How do you mount it if someone doesn't change the program?
It's a very big picture, and actually that's what I'm trying to paint, is how do you get to that point? And it's bigger than any one industry, and that's what the ecosystem is about, because in order to, and it's a kind of a spoiler for what I'm going to talk about later, in order to trust data from the device, you have to be able to trust that device. In order to trust the transmission of that data, you have to be able to trust the network. In order to trust that device, you have to verify that it boot itself up and that it wasn't changed and nobody tampered with it, right? In order to trust that tamper and that device's boot up, you have to trust the supply chain and the provisioning providence process that got it there. So there's 4 chains of trust and accountability that have to be maintained in a big ecosystem before you can trust data from the devices. That help? So we started looking at this in the last training, and I think everybody was here, and I divided this up and I said, really, when you categorize networks by their components like this and how, businesses all have these different networks. But there's some very main oppositions and opposing types of big contrasts when it comes to them. And here I'm going to start looking at a few of those main contrasts. And this one I talked about is briefly, right at the end, is what is prevalent in critical infrastructure versus IT systems. And all those things that were major clashes that I identified are between these two types of networks. So you have internal proprietary perimeterized networks that have physical components. And then you have external, open, deparameterized, cloud, internet, and those two are coming together, and they're opposite in every single way. There's A is the physical, B is the virtual. So how do we integrate the physical, virtual? If you're collecting data and big data, you just care about the data. It's all virtual, right? Well, if you're on critical infrastructure and OT, you care about the physical. This connection is really the foggy area. So what do we use to bridge? And security is the thing that bridges it. You have to bridge not just the technical, but the organizational, logical, physical, regulatory, process, protocols, and policy all have to be addressed. And the next big contrast to talk about here is this, once again, opposite blocks, external parameterized proprietary and internal deparameterized open. So this one appears in one of these other trust accountability chains as I was talking about, the supply chain, where vendors and network users want to have multiple vendors. Utility companies want to have more than one vendor. Each vendor has their own way of provisioning, keeping track of their supply and everything, but when it gets to the end use, it's all thrown out the window because you have multiple and you don't even care about that tracking. So there's just throw it over the wall, and on the other side, they fend for themselves. So what we kind of look at with ecosystem organization is how do we include this contrast and bridge this divide and also include it into the ecosystem so it connects those four accountability chains. And if you look at, if you could move one category in each of those, so you take the, sorry, these kind of get, by taking and changing the proprietary and making some kind of a uniformity between the different vendors, knowing that they're going to go on end system networks, and change the C block proprietary to open, you move it over to G, and then also changing the deparameterized to parameterized. So you got to put parameters on open standards. So bring those two together, then you just focus on the internal to external. So this particular contrast, though, requires more than one company, more than one industry, and it's really a whole ecosystem.
Chris, can you give me an example of what you just said?
Example. The example really is that the supply chain. You get meters coming into a utility company from 3 or 4 different vendors, okay? They all have their proprietary way of programming, provisioning, putting the network credentials in them, and when it gets to your network, their whole tracking system, their chain of trust doesn't matter because you have 4 different types of chains of trust on your network and they don't work together. So those methods of chaining trust through the supply chain need to come together to a standard that's open between all 4 of them so that you can parameterize controls, so no matter what stage in the supply chain ecosystem it goes through, all of them have the same requirements for transferring trust from one organization and one level to another. This will become more apparent, and I think I'll answer this question a little bit later on. But just, I guess from this slide, take that we're looking here at the providence, that getting the device from inception to operation, and how do we put that, the security involved there, into the operational security.
So see that as a time where once it's in operation, make sure that you get it retained.
Yes, and part of the, I would say there's the providence and an onboard system integrity that come together in the kind of the firmware updates and the recurring updates that you do to it. And those two chains also have to merge. So this other contrast, though, you see E to F, is with organizations. Most of these devices, and coming from a background in microcontroller manufacturing, they design them to operate independently, standalone. But then they're getting put on networks and they want them all to work together. So being able to change that kind of assumption that they don't all work together or all stand alone, that they have to work together from the design, is something that is very, this particular contrast shows that at the end of the use, they want them to be on network together, but their design's thinking about them standalone. won't focus on this one too much. It's more value for a manufacturing group. But we talked about now looking at opening up that and looking at where the blocks, the network types, where information crosses them, and identifying which security management you have to focus on when they cross. And you see that once again, the one in the center is really where critical infrastructure is those two opposing. And that's kind of why I started this model, is to show the oppositions in critical infrastructure. But it's actually working for this model is working for me in the whole industry approach when I go talk to people of other industries from critical infrastructure or IT, where they all really have that different focus, as I talked about early on in the last training. But if you look at the roles of these management areas, in information technology, business-focused roles, policy, risk, standards, regulatory, trust, and then there's a logistics-focused, where supply chain management of secrets, which like unique identification, things like that, certificates, things that you're managing that are trust or secret-based, and user management are logistics-focused. And then technology-focused really is only the boundary management and data lifecycle. And this is why you see that, we're at ISAC, where they're focusing on data, because that's where the technology focus is in information technology. You move over to control systems, and this whole chart kind of moves down, where there's less business-focused, and logistics then change a little bit, where regulation, and this is why the NERC-CIP is such a big task, and a lot of utilities are spending a lot of money organizing NERC-CIP, because it pushes down to a logistics focus from a business focus. And then the technology focus, because of the mass amount of devices out there, things become technology focused that were not in information technology. That they're now either needs to be, or they're behind the scope on getting these technology focused solutions. And the same when you look at tasking, the people, how much time is spent in information technology in different management type functions for security by people versus process ones, and then technology is really very minimal. It's that boundary management. And that's what you see with firewalls and fire scanning, and they're managing the boundaries between hardware to operating system to application, application to the wire segment to wire segment, internal to external company, and that's really the only place in information technology that technology is focused. Move over to industrial controls and you have a similar thing, where what happens is these functions, these security management things get pushed down because of the mass unmannedness of all these functionalities, to where technology-focused things need to include the data, the meter data management, the collection of data, the storing of it, and then the management of trust and secrets, as well as boundary, which we talked about before. So, and this is what I talked about at the beginning here, is these 4 trust accountability chains. Maintain each one unbroken. So if you look at, to manage the security across the ecosystem, you have to build the trust accountability chains to be able to trust the data, you have to trust the network. To trust the network, you have to trust the individual device. To trust the device, you have to trust the supply chain that got it there. So the 4 trustability accountability chains are data, product lifecycle, onboard system integrity, and network systems. So I refer to these a lot throughout all my training, and how that each security management area builds these trust accountability chains to hold true on the ecosystem. So now I'm changing gears a little bit. I'm going to go to an example of 2 large companies that I did some work for, and measuring, kind of, first of all, this slide is a step back to, in the industry in general, so a little bit of history. How do we measure success of a business after since the industrial revolution? Are margins, costs, profits continuously tweaked and optimized? And productivity improving, squeezing, higher performance levels in the organization. Before the technological revolution, customers could easily change products. If you have a physical machine, or not even machine, a physical broom or a shovel, the thing that you buy, you spend your money based on the quality you want. And if you didn't get the quality, you move on to the next brand that might later, or if you don't want to pay as much, you move down in quality. So after the technological revolution, what we have is the goal has shifted from standalone product focus to ecosystem, products that work together now. And maintaining and building the ecosystem of complementary products is the focus of companies instead of individual products. So though they're kind of tweaking margins to get a better product in something, a next generation of something they've already made, costs are cut on initial products to get them out the door, to get somebody into the ecosystem. And you see this with any major platform. You pay less for the phone than you do for all the accessories, and then you get sucked in, you have to buy their software, and everything that kind of goes along with it. So this is kind of to say that just introducing you to ecosystem as a whole when it comes to products, even though we see this all the time, we know it. The manufacturing industry has really made this large shift, and I've seen it in the last 10 or 15 years where everything they do is focused on getting the customer in the door and then making their money down the road. And it's a change in focus in the business model from literally just 20 years ago when the individual product was more of a focus. So I'm going to talk to you about two very different business models when it comes to these ecosystems. On the left I have customer product driven. And I went to consult a number of years ago for a company that was very large, global recognized brand. And they said, hey, we have a security problem. So I'm a security guy. I go in and my work was in applications, how to add security that fixes their needs. For them it was money, profitability. How are they going to keep track of their products and make money off of them? So when I first came in and talked to them, they said, we have a problem. We have our recognized worldwide logo. We did some research on the products we have out in the field, and 40% of what products are everywhere that have our famous logo on, we don't know where they came from. And I was like, wow, how could this big company get that far out of control of their products at 40%, where they don't even know where they were made? They're tracing the origins and trying to find out. And the thing is, they found out they couldn't trace the origin because they had a product-driven model. Now, it didn't take long to find out who, because we did work for them as well, who had another model, and what I would call a cybersecurity controlled model. And that was the Apple Corporation. Early on in their existence, they lost some IP, so they decided that's never going to happen again. So they implemented some pretty strong IP protection internal to the company. And what it became was security controls across the board to enforce their ecosystem. And we all know this today as, Apple products have good quality, they cost a lot, you pay their prices if you want it, you get their software if you want it, you do it, you have to. What they've done is they've successfully set up a cybersecurity controlled ecosystem. And they had slower growth adoption at the beginning. Most of you remember that kind of Apple have struggled and had some problems. And like we'll say the Android products or the PCs took off because everybody's making stuff for them, adopting. And cutting edge innovations on the product consumer driven side. On the ecosystem side, more cutting edge quality for the ecosystem control, which wasn't apparent external to the company for years. Both reduce costs on the initial product, like we talked about in the last slide, as a business model because they had to compete. But what happened, and this is where you see started a difference, is on the product consumer driven side, they had an uncontrolled vendor base, uncontrolled ecosystem. On like an Apple computer side, they were able to control everybody they worked with, set them up positive control, we'll say the whitelisting versus blacklisting. And on the product-driven side, they didn't even have a blacklisting. They couldn't deny anybody from operating with them. What it leads to is down the road, the market-driven pricing leads to saturation, but on the cybersecurity control side, they have pricing controls, and they can control their numbers and keep from being saturated. On this side, they had open bill of materials. Everybody could bounce off of them. Supply chains started flooding with counterfeits at every level in it. But on this side, they had market traceability. This is all ecosystem. Hopefully this is answering some questions about what I mean by ecosystem and these 4 trusted accountability chains. The market size here is unknown. They don't even know who's playing, who's making stuff. And what happens is a lack of security ecosystem controls. They can't support warranties, or they're supporting counterfeits or just unknown quality. On this side, though, they have the ability to maintain that control of their aspect of the business. And at the end here, it leads to a high quality perception in the customers versus low quality. And this is how they did that, high versus low quality. It happened over years, but this is what did it. They have this tight cybersecurity controlled in the internal of the company. And another thing is now they're able to keep their pre-Asian market boom R&D expenditures, reinvestment, life cycles, time to develop new products, and they're keeping their pre-Asian boom business model because they've enforced it through there. So what does that kind of lead to is on the consumer market-driven side, shorter prime pricings on new products. So they come out with a new product, they can only get prime pricing on it for a couple months, and this is the problem that the company I consulted for was having. They initially would have prime pricing for 2 years. That went to a year and a half. That went to a year. That went to 8 months. Pretty soon they could only get it for 6 months or so. Apple, they still have prime pricing when they obsolete a product from a previous version. They'll still be able to get a set amount of pricing on the older version products. Inexpensive counterfeits versus traceability in products, and unexpected shortening time to development cycles. And it just led to a spiraling down business model to where now this company that I consulted for is no longer even in business. Low quality perception because everybody could make a product. They didn't have innovation for the next product because they shortened their R&D. Their employees are bailing. And it's just totally the end result you can see. And you historically know both of these companies. So not bringing up a name, but you know who the other company is. So when I start looking at security ecosystem, what we need in critical infrastructure is to map to this security ecosystem that works by mapping to the 4 trust accountability chains. Controls on products forced by cybersecurity, electronic communications, network authentication, software, cross-product compatibility, and inter-organization compatibility. Networks of products, physical networks, people, organizations, interconnected when they exchange data. Looking at that security management model, everywhere that we identify that changes happen in these type of networks, map and identify and define what the interface is and what tasks and things are done at each section of the ecosystem. And so interfaces at each ecosystem touch point defined and have handoffs for the data and what's happening for each one. And each time a handoff or interface is done, cybersecurity controls to enforce the way that we track and maintain these interfaces. These touch points, though, scan multiple industry organizations, and we'll get into these in the next couple slides here. same feature, this is what I'm using, and you'll see how that it bridges the gap between the physical, the virtual, and the business. I showed these in the last time I talked, but the 4 collection types that really have to be identified in the ecosystem: computers that connect, people that connect, product chains, which I think you get the picture of in the business, last couple slides on the business models, and then organizations. So determining which security management areas need to be addressed, and then which collection types are relevant for each industry touch point, and what activities at each touch point should be maintained. Each of those 4 trust accountability chains, the accountability of transactions of each party, the ability to recover. So a big thing we have in cybersecurity issues is if something does happen, how do we recover? It's an unknown, undefined. But if you have a set trust accountability chain, and you know at the 4th link in the chain it's broken, and you have designed in the ability to go back to the level below and have them reset the trust for that next level, keeping that chain and being able to go back and recover is an important feature that really doesn't exist in the security world today. And then secrets management industry, we'll see in the next couple slides where I start showing the entire ecosystem and where each point things need to be managed and programmed, provisioned, and then used for operations that are secrets in each device that floats around out there. But things that are needed in the inter-organizational control, cascading the trust, cross-certification. So even in operations now, the utility industry especially talks to other industries players. So all utility companies need to talk together. So you have the need now for cross-industry and roving loads when we get the electric vehicles becoming in mass production that are going to migrate. So these type of inter-organization controls are important to add in to this ecosystem management process. So industry collection interfaces. I have here, and we're going to look at each one a little closer. This is a drawing of the industry for looking across the entire ecosystem, defining the collection types, the different color lines you see. This is where computers connect. This is where providence, the programming, the supply chain, the logistics of moving. This is where the yellow is people. So if we removed everything, it was just people, and we could start focusing on technology. And then the green is where organization boundaries cross. Now, I'm sure this is not all-encompassing, and this will grow and expand and change and migrate over time. It already has for me. But mapping the effective coordination to each security management area is kind of where I'm working now with helping and defining this effort, in my case, we'll say. But if we'll start looking at this in a little more detail, and I'll look at this level here. And at this level, at the very bottom, you see education, research and development, and design. And I see they're all kind of people, the yellow. They're not as much you come up a level now, and you have your integrated circuit design and your software driver development. So your 2 separate computer science, electrical engineering, and kind of operating system and firmware. And at this level in industry, it starts out where all the designers from both sides, hardware, software, need to start interfacing to think about security even at this level. Okay? And off here to the left is the first piece of how you start the secrets management and the programming. These devices now are programmed with uniqueness and cryptographic keys. And they have to be thought about at this level, but not just for this level, for how they work at the very top in the corporate structure. So coming back to here, the next level is take a step up and you have now subcomponents going together. So you're making computers instead of just individual components. On the other side, you're developing applications, and then you're integrating them in the middle. And the next level is programming to go onto a network or a network vendor. So now you're taking these individual components and you're sending them to a vendor who's going to get them ready to go on a network and install them. And they're going to manage their own vendor secrets. So at this point, you have to decide, or there's an insertion of a providence that says, yes, now we had the uniqueness at the factory level. Now we're making the uniqueness for the machine. Now off to the side here, I kind of did this separate because there's a piece that connects to the security ecosystem that controls the secrets for configuration and development lifecycle. So in the software and hardware, configuration now has to link to secrets management for the ecosystem to be able to know that I'm creating a software certificate that meets my end use need and is also fits in the rest of the ecosystem. Or I'm managing the secrets for the programming of new firmware, but the configuration and management of it. Oops. And going back here and looking at the next level coming up in the ecosystem is the logistics, the shipping of these devices around. Now, the level below and this level almost integrate because a lot of the network programming and the supply chain kind of happen coincide and together. But at this point, it's the device itself, onboard integrity, trust accountability chain comes in for the first time. Before we were in Providence. But now this onboard integrity has to link to the Providence in the management of how security is done with the secrets, the uniqueness, the application certificates, all has to link together. So the security ecosystem needs to transfer up this chain to this starting of this next chain of onboard system trust. The next level we're familiar with meter data management, collection of data from sensor networks. So now this is kind of in between, or the base step of once it's provisioned on a vendor network, which when I say or end use network, which would be a utility company, an oil and gas company. And you see, I keep referring to these in general terms because although most of us think of electric sector, and the Internet of Things is really every industry out there. Railroads, oil and gas, electric, gas pipelines, factory automation, HVAC. So a couple people put slides up of Internet of Things, and when it comes to ecosystem, all those things start to come together because at some point in time in the life of probably, I don't know, everybody in this room, but because maybe I don't have that much longer to live, but everybody in this room has different times that they'll be around. But at some time in our lifetime, everything that plugs in will have to negotiate and communicate for power. And can anybody say that that's not coming down the road? No? Just what are your thoughts on that one? But now at this point, you're hooking into the next trust accountability chain, which is the network trust and the synchronization. So now you're synchronizing the network, rotating through security posture, and all this has to link to the onboard system integrity and then down to the providence where we came up through. Now all these, kind of the management of how these things are all linked together require a base component. We'll say like a TCP/IP stack for network communications. There has to be a base security TCP/IP stack in every product out there to make it work at every level in this ecosystem. Oops, went the wrong way. So, and this one I kind of did separate, but it's, application test, the environments, once it's in put in and integrated the configuration management of the end user customer also has to be integrated into the security ecosystem. And the next level is now how the data is used, integrating it into the business model and the actual enterprise systems. And this is where the fourth trust accountability chain comes in, the data lifecycle. So now you integrate into these levels, and if you want to have 100% accountability for electromechanical controls, you have to have proof of origin on your data. So if you can trust the network, you can trust the device that produces the data, now you can stamp a proof of origin on that data. And this becomes usable then for the life cycle of the data. This next level up, corporate secrets management, governance, identity access management. You see the one on the right is how this fits into the corporate applications that a lot of us are familiar with, Active Directory, the network. But here's a piece off to the left that you don't see right now in the corporate environment. And you see the red network, it linked all the way down to provisioning of network, all the way down to provisioning of factory. It's the over into the configuration management. It's the maintaining of all those secrets that, like I said, with the Apple ecosystem, at every one of these levels, they have to have the secrets management to pass these around and keep them secure. And then at the top end, you have kind of the industry standards, government regulators that link back around down to the bottom, the new designs and integration. And see, this is where I talk about the red, the networks. I've separated out just looking at what I had in red in the other, and I've color-coded it a little bit different to say, you know, now I have data utilization networks in blue, the secrets provisioning in red. And you see the secrets provisioning starts here with the hardware individual component, manufacturing subcontractors, division of programming, up to network vendor, inserting things that would be used for keeping a network together, and then up into corporate secrets management where the operational network, all these interconnected to keep this secrets management ecosystem. And you see the process support are also linked in, but that's the kind of configuration management and things that also require the link into the security ecosystem for the production of software, or up top, the integration of applications and things into corporate. And so we removed all but the networks. I kind of said all this. So now we look at the provenance. I have a different, and I left on the provenance, I left the inter-organization transfers. So this is where products, and you see on the right and the left, well, the light blue, dark blue, I've separated hardware and software. So the security ecosystem for products is both of these coming together to operate in the end devices. But all these management areas be addressed in order to manage the provenance. And I know maybe some of us aren't too interested in this particular supply chain provenance, but in order to make the devices and the data usable for the network, this is the first step. This is kind of how we pull it all into everything coming together and working. And this also has to do with your updates, factory updates. How can you provably use them repeatedly? Human networks in yellow. Debbie's giving me not too much time, so all the things that cybersecurity eventually, cybersecurity is, doing the things that we do in the real world, but in the virtual sense. And eventually, everything that we do in the real world will migrate to this virtual environment. And these are just some of the list of things that we might not think of that really become, in the future, all integrated into the security ecosystem and have to be done virtually. In order to do that, cybersecurity has to be implemented for each feature and, in a lot of cases, defined how we're going to do it.
Awesome. Thanks, Chris. Appreciate it.
Sure.
Very good. And we'll roll into your secrets. Secrets and records management. Is that what your secrets?
Secrets management is going to talk about the red network, where I briefly said, you know, at every level in the ecosystem it programs. But I look into what's required in the TCP/IP stack or the DNA of each device to make them all work together. So like you can pass this device around through the ecosystem and every step does a portion of the secrets management updates or programming or provisioning to make it all work together.